this is Mr. T. I'm going to, in this tutorial, talk about solving systems of equations algebraically by using what's called the substitution method. Remember, when we're solving a system of equations, we're looking for a point, an xy pair, that make both equations true. Since the same y value has to make both equations true, the number that's going to be this y and this y are equal. So these two y's are equal. If those two y's are equal, that means these two expressions also must be the same. So by substituting, say, this 2x plus 5 of this y in for here, we can rewrite this as 2x plus 5 equals x plus 4. So by substituting 2x plus 5 here into that y, since the two y's are the same, we now have a single equation with only one letter. We know how to solve that. We can get the x's on one side by subtracting x's, and we can get the numbers to the other side, and we get x equals -1. Now we have to find the y value, and we do that by plugging this x back into one of the original equations. So if we use the first equation, we get y equals, and now we're going to put this -1 in for the x, -1 plus 4, or y equals 3. So our solution is -1, 3. If we wanted to test it, we could put -1 and 3 into the first equation and into the second equation for the x's and y's, and it would make both equations true. In the example we had a minute ago, both equations were solved for y. In this situation, we have one equation solved for y and the other equation in standard mode. Again, the y value in the two equations at the solution is the same. So in this time, we can take, since we have this y by itself, that expression is a substitution for the y, and we can put it into the first equation. So we're substituting from one equation into a different equation. We never substitute into our own equation. So here we get 5x plus 3, and I'm going to replace the y with what its replacement value is here, -5x plus 16 equals 4. Again, by doing the substitution, I now only have one letter, and we can use our algebra for solving that. So we have to distribute the 3. And we can combine like terms here, so we have -10x plus 48 equals 4. We can subtract the 48. So we have -10x equals -44. Divide by -10. And we have x equals 44 tenths. And we can divide that by 2, the top and bottom, to reduce the fraction. And we have 22 fifths. And we had negative divided by negative is positive. To find y, we have to take this and substitute into either equation. Since this already has the y here, we'll substitute into this equation here. So we get y equals -5 times 22 fifths plus 16. The 5 cancels out here, so we have -22 plus 16 for y, or y equals -6. So our solution here is 22 fifths for x and -6 for y. In our last example, neither of the two equations are solved for a letter. So if we want to use substitution, we have to pick one of the equations and solve it for a letter. The easiest one is going to be to solve to get this x by itself. So we get x equals 5y plus 9. We can now substitute that into the other equation for the x. So we don't always have to substitute for y. So now we have 2 times 5y plus 9 plus 3y equals 5. Distribute 10y plus 18 plus 3y equals 5. Combine like terms, 13y and subtract the 18 equals -13. Divide by 13, and we get y equals -1. If we put that back into this equation, we get x equals 5 times -1 plus 9, or x equals 4. So our solution is 4, -1.